Good morning, everyone. My name is Meisam Mohammadi. I'm from BASF, and I'll be talking a little bit about flexible 3D printing. A little bit about BASF. Our booth is right in front, so feel free to stop by and see our portfolio of chemicals, including 3D printing. So BASF is the largest chemical company globally, and we are the largest manufacturer of TPU and MPU. So those are some facts about BASF. Our group for 3D printing is around 240 people. Majority of them are located in Europe, but we have an applications and commercial team in North America, 18 people. So these are the partners that we work. We have over 800 different combination of materials for 3D printing for different technologies. So we divide it into 4 categories: filaments, photopolymers, powder-based, and software simulation for 3D printing. Here is the portfolio, the TPU line, again, as I mentioned, and then polypropylene and nylon 11-based materials are our powder portfolio for 3D printing. So we have the nylon in SLS, but we have polypropylene and TPU in pretty much all powder-based technologies. Then our photopolymer, the same thing, I put the flexible one. We have different categories of photopolymers also ready to print. And the same is with filament. You can see we have 4 different flexible filaments for 3D printing. And then we offer simulation, which is the lattice design and design for additive manufacturing. And we are the only supplier that offers life cycle analysis on materials and also printed parts. So that's something that we started in 2024. You can get life cycle analysis of printed part as a part of sustainability effort that BASF is putting and bringing into the market. So I want to get into the TPU. Our TPU, I just put examples of applications here in a nutshell. So we have a material that is heavily data-driven. So we have done a lot of testing on it. It's a highly recycled material, and it is easy to print, and we offer solutions for coating. We offer solutions for lattice design for it. So the material that we use, the actual material, is semi-hard elastomeric material, but with lattice design you can go very soft down to around 20 to 30 shore A, all the way to 88 to 90 shore A of material. And then the application, I put some examples in healthcare, consumer goods, automotive seats. That's what we see quite a lot, and some of the seals and soft touch toolings. I'll give some more examples. We have some of these parts actually in our booth if you want to stop by and see them. So these are the tests that has been done on the material, like all the way from cycling loading and how long would it take to break it for consumer goods, and then we have flame resistant tests, skin contact, recycling a different type of bonding that you require for basically attaching flexible materials together. So these are some examples of the application for it. The first one is spring spacers, are the parts that they use for performance cars when they are transferring them. So usually dealerships, they remove them. So the material that we offer in 3D printing is very similar to the type of TPUs that are used in spring spacers. Actually is offered by BASF for injection molding, but because of design change and design iteration, they needed over 1,000 of these parts to train technicians and also use it for bridge production until the new parts are coming in. So this is another examples of using 3D printing, but with flexible material that offers the performance of the same as injection molding or traditional manufacturing, to bridge the gap between design change till you have your final parts from the traditional manufacturing. This is an example of consumer good for mass customization. This is a protective gear for wrestling helmet. So the customer printed the parts all in one piece, and as I mentioned, we offer having different flexibility in different parts. So the whole helmet was printed in one piece, and the customer basically calculation was they saved around 4 months on production, and they saved around 500K in tooling cost, and of course over 250 gram reduction on the weight. So this is another example of 3D printing for mass customization using TPU. And the last one is for medical application. So the blouses that are used for cancer treatment, for radiotherapy, usually are the generic one. Well, right now, one size fits it all, but like usually for patients to have very targeted radiotherapy, they need parts that are very accurate at wrapping their body. So this is an example of a soft touch feel of a material that can be around the skin and can have skin contact for medical applications. And of course, you can see that it was a 40% reduction in the gap between patient's body and the part for more accurate radiotherapy. And of course, it was saving 30% of time for the clinical work. Overall, it was some of the examples. You can see more examples and more about our material with the QR that I provided. I'll be happy to answer if you guys have any questions. Thank you.